Galvanometer with a coil of resistance G is equal to 12 ohms shows a full scale deflection for a current Ig is equal to 2.5 milliamps. You have to convert this galvanometer into an ammeter which is capable of measuring 0 to 7.5 amps. It's example 87. If you have to convert into ammeter, you're going to connect a row resistance in parallel. And what was the formula? Galvanometer into a resistance shunt in parallel. It's this is Ig into G is equal to I minus Ig into S, correct? So S itself is Ig into G by I minus Ig. So you have I here which has been given, this is the capital, and Ig is 2.5, capital G is 12. So with that you can find the resistance that you have to connect. I'm going to the next sum. Similarly, they've asked you to convert that galvanometer into voltmeter which is capable of measuring 10 volts. So if you're going to measure convert into voltmeter, you have to connect a series resistance where it's Ig into G plus Ig into S is equal to V. So S itself is V minus Ig into G by Ig into S, correct? And V is 10 volts. Ig is already in milliamps. They've already specified this is Ig 2.5 milliamps. Galvanometer's resistance also has been given as 12 ohms. And then Ig, and what is this? S கிடையாது. S தான் கீழே வந்து Ig தானே எழுதுறோம். S அப்படி கீழே வரும். You want write S, right? So only Ig will come down. So then just do the calculation and leave it like that. I'm going to next sum, okay? So next is sum where is example 91, where in a galvanometer there are 10 divisions per milliampere is the configuration in a galvanometer. But the division for every milliampere இருக்குங்கிறது அது வந்து configuration of the galvanometer. But they are saying the internal resistance of galvanometer is 60 ohms. If a shunt of 2.5 ohms is connected to galvanometer, okay, and there are 50 divisions in all. அது கனெக்ட் பண்ண அப்புறம் பார்த்தேன்னா there are 50 divisions in all. Okay, 10 divisions is for 10 to the power minus 3 amps. For 50 divisions, what is the value of current? It will be 50 into 10 to the power minus 3 by 10, which is 50 into 10 to the power minus 4, which we know is 0.50 into 10 to the power minus 2, or as 0.005 amps. So this is the current which has to be taken as Ig. Okay, so then the question is what maximum current can this galvanometer read? So they are asking for maximum current. So they are asking for capital I. And the galvanometer is getting converted into an ammeter. So you have a low resistance in parallel with it. So then the shunt is in parallel. This is 60 ohms. This is a shunt resistance which has been given to be 2.5 ohms. They've already given this. And you know that the formula itself is this Ig into G is equal to I minus Ig into S, correct? So S itself is Ig into G by I minus Ig. So Ig is 0.005, and the galvanometer's resistance is 60 ohms. By I itself is you don't know, you have to find, is it? Minus Ig is 0.005, and the shunt value is 2.5 ohms has been given in the question. Just cross multiply and find the value of I. So that's this question. The I will turn out to be 125 milliamps. You can open your Aurora and see for the answer. Okay, so let's go to next sum. Next is sum that I would like to do as something that's marked with a CBSE here. Example 96. A galvanometer of resistance capital G can be converted into a voltmeter which can measure V 0 to V volts, connecting a resistance R in series with it. Yeah, obviously R in series with it. How much resistance will be required to change the range to measure 0 to V by 2? So let's write first one. What's happening is the Ig into G plus Ig into R is equal to V, correct? So from this, if you're going to group Ig into G plus R is equal to V. Therefore Ig is equal to V by G plus R. Using the first one, you're writing one equation to find what is the value of current Ig, small ig, correct? Now next thing, you have to get a V by 2. To get a V by 2, Ig, you write the form, the same current has to flow. That's the difficult part about this sum. The same current has to give you the voltage of V by 2 plus a G plus R dash, the new resistance that you have to connect. So the voltage alone becomes half. Means you have to retain the same Ig, you have to retain the same everything, only V by 2. So then therefore Ig is, you can substitute that here, V by G plus R is equal to V by 2 into G plus R dash. V and V get cancelled. G plus R is equal to 2 times G plus R dash. So G plus R is equal to 2G plus 2R dash, correct? Taking the G that side, you get a G. You get a R minus 2R dash. What do you want? You want R dash, right? So then group and find what is R dash. Don't do this. Just find what is R dash. So it's R minus G by 2 is equal to R dash. Just grouping them, you get this as answer. So that's the value. It's a peculiar sum. Very difficult to do this sum. Provided you should understand whenever they give you sum this, you should find what is IG. Using the same IG, you have to find what is R dash. Changing the voltage around to V by 2, something very important. You have to learn it. Okay, that completes the sum. Then as the next sum, which is example 98, I'm sorry. The voltmeter reads 5 volts at full scale deflection. For the full scale deflection, it reads 5 volts and is graded according to its resistance per volt at full scale deflection as 5000 ohm per volt. Okay, it's graded according to the resistance per volt. What is given is a resistance per volt. I don't know what is that. They've given resistance per volt. The voltmeter reads 5 volts full scale deflection. Actually, this question is about a galvanometer getting converted into voltmeter. So when we read, we should only think of a galvanometer which is converting itself into voltmeter. Voltmeter now reads 5 volts, which means the maximum voltage is 5 or there's 20 volts here. So the maximum voltage is 20. So I don't know. Let's see the question. The voltmeter reads 5 volts and shows a full scale deflection and is graded according to the resistance per volt for a full scale deflection. It's got 5000 ohm per volt to be the resistance. How will you convert it into a voltmeter? Which means this is about galvanometer. How will you convert it into voltmeter? Oh, the same voltmeter. It's voltmeter only. It's going to convert into measuring 20 volts. Similarly, it was V and that was V by 2. Now it is 5 and that is 20. Isn't this more or less a similar kind of sum? So how will you convert it into voltmeter that reads 20 volts with full scale deflection? Will it still be graded as 5000 ohm per volt? Question ketirkan. Will you prefer the voltmeter to one that is graded 2000 ohm per volt? 1 second, hold on. See, this sum is a special sum where normally we convert a galvanometer into a voltmeter. How do you convert a galvanometer into a voltmeter? By connecting a resistance in series. So this is an already existing setup where you have a galvanometer and one pre-existing resistor. This can measure 0 to 5 volts. This can measure 0 to 5 volts in the existing setup. Now you have to increase this to be capable of measuring 0 to 10 volts. So it's a voltmeter which is going to be enhanced. And how can you do that? Let's now itself know that by connecting another resistance R dash and additional with the existing resistance, you can keep on increasing the resistance. The more resistance, the more will be the ability of the voltmeter. So then to enhance it, you have to do this. So this is the R dash. So in this, let's find what is the current. Okay, whenever they give you the voltage difference, you always find the current in the initial thing. Ig is equal to V by, what is V? It's 5. By the original resistance is just R. Okay, they have already given the resistance to be 5000 volt, 5000 ohms per volt. 5000 ohms, then for 5 volts it's 5000 into 5. So 5 by 25,000. So 5 5s are 25. So 1 by 5000 amps is my Ig. That is the same Ig which is going to flow through for this side also. You know how we do it? It's the same Ig which is 1 by 5000 amps is going to flow through here also. Whose formula is again V by R, but in the V you don't substitute the already existing V, just you are going to make it into 20 volts. Already 5 volts has got R, so the extra 15 volts is going to have this R dash. Is it easy? So extra 15 volts is going to have this R dash. So R dash itself is 15 into 5000. 15 5 is 75,000 ohms. That is the new resistance. Therefore, you understand that apart from this R, you're going to connect a 75,000. You already know what is this R. It is 5,000 per volt. Means for 5 volts, already existing volt is 5 volts. So, it's 5 5s are 25,000 volts. Is a pre-existing resistance plus 75,000 will become 1 lakh ohms, correct? Is the total resistance now, because they both can be added. R is this much and R dash is this much, and R plus R dash is 1 lakh. For the entire voltage of 20 volt, this is the resistance. Suppose they ask you per unit volt, then divided by 20 and write whatever is the answer. So it's 5000 ohm per volt. It's resistance per unit voltage. If they ask you like that, okay, this is a beautiful question. Okay, so then I didn't deal with it last class, right? No, okay, so then that's some. So let's go to next question. It's the example 100. Example 100, a voltmeter of resistance 400. The circuit like this is given, okay? 84 volts, 100 ohm, a 200 ohm. A voltmeter is like this. A current is flowing like this, okay? A voltmeter V of resistance 400 ohms. This is an inbuilt resistance. The voltmeter which is 400. These two are parallel. 100 and 400 are in parallel. So this is like a parallel resistance. R1 into R2 by R1 plus R2. 100 into 400 by 100 plus 400, which is 500. So then 0, 0 get cancelled. So you get a 400 by 5, which is 80. Is the equivalent resistance, R equivalent, in the case of two parallel connections. Okay, so 80 ohms. So this is 80 ohms. This is 200 ohms. So the equivalent resistance is now 280 ohms in series, correct? So you know the total voltage is 8 volts. So I is equal to 8 by 280. So it's 4 by 240 or 1 by 60 amps. Is the current 1 by 60 amps is the current that's going to flow through this. So once you know the current, I'm telling you, just come back here. This is also 1 by 60 because here it will get split, I agree. But here it will be 1 by 60 only when it comes out. So 1 by 60 is the amps. In resistance is 200. So you get 1 by 60 into 200, which is 10 by 3 volt. Is the voltage across this. Correct? If the voltage across this is 10 by 3 volts, obviously that voltage across this will be, what is the supply voltage? 8. 8 minus 10 by 3. You agree with me? 8 minus 10 by 3, which will be 3. 24 minus 10, so it's 14 by 3. Thus you get the voltage across this to be 14 by 3. I hope my answer is right. No? Okay, let's do it once again. Is the current correct? Is 1 by 60? Is the equivalent resistance correct? 280? Okay, the voltage is 84 by 280. Yeah. That's where we made a mistake. 84 by 280 is what is wrong here. So let's do the calculation again, which is, what is it? 4 2s are 8. Can you listen here? 4 2s are 8, 4 1s. So see the mistake. 7 4s are 28. So 7 tables can get cancelled. When I'm calculating, you be careful. Okay, 3 by 10. So this is 0.3 amps. So I made a mistake there. Okay, so then therefore, this is 0.3. 0.3 amps. So what is coming out is also 0.3 amps. Multiplied with this resistance 200 ohms, it will be 2, what is it? 3 to 6, 60 volt. 60 volt. 0.3 into 200 ohms, what is it? No, you're seeing there. I don't want you to see there. I am telling you to see here. I can also see and copy, na. What is the mistake I'm doing and not identifying? Chumma seeing there and correcting me. Use your common sense. What am I doing? 0.3 amps is what is flowing in. The same thing that is going to flow through here. Do you know this resistance is 200? So you know IR will give you the voltage. So 0.3 into 200 பண்ணிருக்கேன். நான் என்ன பண்றேனோ அதை கரெக்ட் பண்ண. அவன் என்ன பண்ணிருக்கான்? I'm not bothered. What is the multiplication of this? 600. Yeah? So 60. So how can it be 60 volts while this itself is just 8 volts? You understand my problem? I think we have made a mistake here. Can we just correct it again? Shit. What is I? I is equal to V by equivalent resistance, no? Did I do the equivalent resistance? Which is 8 by what was the equivalent resistance? It's 280, right? Yeah, 280. It is 84 by, it is 84, baby. You should have corrected me here that I've written it wrongly instead of correcting me on my method. Method is not incorrect. Something that I've copied is wrong. I got here to be a greater value when it was 8. It is not 8, it is 84. So I hope what you have to notice, she can't see from there probably. You guys can see it here. Okay, let me also slow down a bit. So this is 84 volts. So then current itself is 84 by equivalent resistance, which is 280. Did I get this as 0.3 amps? Yes. Yeah, but I wrote here 8. That was the issue. That 0.3 into 200 will give me 60 volts here. And if it's 60 volts here, 84 minus 60 will be 24 volts in here. Therefore, from this end to this end, it's 24 volts. So what is that they want? What will be the reading in the voltmeter will be 24 volts. The same potential is what is going to show in the voltmeter. Calculate the potential difference across 100 ohm resistor before the voltmeter is connected. Before the voltmeter is connected, the 400 will not even come into play. So it will be 100 plus 200, it will be 300 is the equivalent resistance. Correct? So then I is equal to V by R, which will be 84 by just 300. So 84 by 300 will be, it's 7 by 25 amps. So that will be the current which is going to flow through. In that case, this is not even there, so I'm deleting it. Yeah? So it's the same current which is going to flow through here and here. That is 7 by 25. Here also it will be 7 by 25. So when you multiply 7 by 25 into 100, yeah, 7 by 25 into 100 is 725 4 is 28 volt. Here it will be 28 volts if the voltmeter wasn't even connected. Are you clear? 28 volt should be, what is the question? Calculate the potential difference. Yes, that's what we have done. Okay, so can I go to next question? It was easy sum. I just put 8 volts there. I'm trying to cross check, but you should always cross check like that. And it cannot exceed that value, right? That's voltage is only getting split among this and this. Okay, so don't let me make a mistake. You guys are sitting like this. It's hard for her to see. So let's go to next sum, which is example 101. A DC supply. Let me draw this. Okay, I don't know what this is. I've never done this sum either. There's an X ohm here, and there's an voltmeter which is 10 kilo ohm, and there is this battery which are like this connected. So many batteries of 120 volts all put together. There's a key, and then that's like this, and this is a voltmeter. There's something called 4 volts which has been written. I don't know what is that, and the current is flowing like this. Have I jotted everything correctly? Okay, a DC supply of 120 volt is connected to a large resistance X. A voltmeter of resistance 10 kilo ohm is placed in series with a circuit of 4 volts. A voltmeter of resistance 10 kilo ohm placed in series, the circuit reads 4 volts. A voltmeter of resistance 10 kilo ohms placed in series with circuit read 4 volts. Yeah. Okay, the voltmeter showing 4 volts as the reading there. Okay. What is the value of X? What do you think is the purpose in using a voltmeter instead of an ammeter to determine the large current? Okay, what do you think is the purpose in using the voltmeter? Okay, let's pass this. ஸோ இந்த சம்மில் என்ன கொடுத்துருக்கான் அப்படின்னு சொல்கிறேன். நான் திருப்பி வரைகிறான். இந்த இடத்துல ஒரு வோல்ட்மீட்டர் இருக்கா? இந்த இடத்துல ஒரு வோல்ட்மீட்டர் இருக்குது. அது 10 கிலோ ஓம்ஸ் ரெசிஸ்டன்ஸ் இருக்குது. அதில் 4 வோல்ட்ஸ்ன்னு அவனே கொடுத்துட்றான் அந்த வோல்ட்மீட்டர் மெஷர்மெண்ட் 4 வோல்ட்ஸு. ஸோ இதில் வந்து இது 120 வோல்ட்ஸ் இந்த எக்ஸ் ஓம்ஸ்னு கொடுத்துருக்கான். Okay, current இப்படி flow ஆகுது. A DC supply of 120 volts is connected to a large resistance X. A voltmeter of resistance 10 kilo ohms is placed in series with which can read 4 volts. What is the value of X? What do you think the purpose of the voltmeter? Okay, now you know that here its resistance is 10 kilo ohms. You know the voltage. You can find the current through here. I is equal to only this part. Correct? I is equal to V by R. What is V? Is 4. What is R? 10 into 10 to the power 3. Which is 4 by 10 to the power 4, which is 4 into 10 to the power minus 4 amps is the current which is flowing through here. Which will be the same current which will flow through here also. So you know the current through this circuit itself is 4 into 10 to the power minus 4. And you know that, let's now take the entire circuit, not just this part. Let's now take the entire circuit. I is equal to V, which is 120 by the equivalent resistance, which will be this resistance X plus this 10 kilo ohms, which is 10 to the power 4 ohms. And I itself is 4 into 10 to the power minus 4 is equal to 120 by x plus 10 to the power 4, with which you can calculate what is x. You can do the calculations yourself. So 290 kilo ohms is the answer. Okay. So as the current in the circuit is very small, can you see the current is so small? Is it? It's 4 into 10 to the power minus 4. So it's such a small current. The ammeter reading will be too small to even measure. Such a small value will be too small to measure. This is an unusual use of voltmeter. This is an unusual use of voltmeter for measuring high resistance. As the current in the circuit is very small, the ammeter reading will be too small to measure accurately. You can't connect an ammeter to measure this. So therefore, you are actually connecting it with a voltmeter, thereby increasing the resistance. And so then therefore, when you increase the resistance, the current significantly will increase. Increasing the resistance, it will only decrease the current. What am I saying? So then this is the unusual use of voltmeter for measuring very high resistance. Because it's high resistance, the current becomes very, very low. Correct? And so then, therefore, instead of an ammeter, we are using a voltmeter in series. What do you think the purpose in using the voltmeter? Only if you connect a voltmeter, if you know the voltmeter is reading itself, you can find the current. Otherwise, if you connect an ammeter, the ammeter will not show you any deflection because it's negligible. Whenever in a circuit there is a negligible current, so that's an MCQ. Whenever there is a negligible current, you can't measure it using an ammeter, then you can put a voltmeter whose voltage will be deflection. You know what will be the deflection in the voltmeter, that will be seen there. And if you know the inbuilt resistance of the voltmeter, only if you know the inbuilt resistance, you can put it in series and thus know the value of the current there. This is an indirect way of measuring the current in the circuit if the current in the circuit is very, very low. So that's this, which is an NCERT sum, which is beautiful. So let's go to next. There's one more NCERT here. One more question, example 70. The maximum torque acting on the coil of area 0.04 meter square. Its torque itself is 4 into 10 to the power minus 8 Newton meter. When the current in the circuit in the coil itself is 100 microamps, find the magnetic induction B. Okay, is a question. Are they talking about a galvanometer? Because we already know NIBA. Torque is equal to NIBA. We have NIBA sin theta is the formula for torque in a rectangular coil rotating in a magnetic field. And when you write sin theta, where theta is the angle between the normal and the magnetic field. When you write cos theta, it is the angle between the magnetic field and the coil itself. Correct? So let's take the NIBA cos theta. But you know, the magnetic. So this is NIBA. We are taking cos theta to be 1 because they didn't specify anything about the angle, so you take it as 1. So T is equal to NIBA. So torque is given. Number of turns is given. Find the magnetic induction. Yeah, so of how many turns? The maximum torque acting on a coil 0.01 coil. So the number of turns is just 1. So NIBA N is just 1. So you want to find B is T by N IA, where number of turns is 1. You know the current, you know the area, you can find B, right, which is 10 to the power minus 2 Weber per meter square. You can also write it as magnetic field to be Tesla. Another unit for it is Weber per meter square, because magnetic flux per unit area. Flux is Weber, area is meter square. So Weber per meter square is another formula for Tesla. Okay, so unit for Tesla. In place of Tesla, you can write that. Okay, so let's go to next. So let's look at the next sum. As example 71, there's an angle which has been given. When the angle is given, the confusion is whether to use NIBA cos theta or NIBA sin theta. You have to see if it's NIBA sin theta, you can use it if the angle is given between the magnetic field and the normal to the coil. You can use NIBA cos theta if the question says the magnetic field and the coil itself. So I'm going to read the question, you can decide for yourself what's the formula I'm going to use. Calculate the torque on a 100 turn. So N is equal to 100. On a rectangular coil of length 40 centimeter and a breadth is 20 centimeter, carrying a current of 10 amps when placed in a making an angle 60 degree with a magnetic field. When the coil makes an angle 60 degree with a magnetic field. Coil making an angle means I have to use only cos theta, not sin theta. You agree with me? Yeah, it makes an angle. Don't see aurora. What I am teaching is what you should stick to for the solutions. So theta itself is 60 degree. Torque itself is NIBA cos 60. So then he would have put sin 30 because cos 60 is nothing but sin 30. He's confusing, but you know that when it comes to the angle between the coil and the magnetic field, you'll use niba cos theta. Directly you put 60 here. Do you know n number of turns? You know the current that's flowing through is 10 amps. B is 3 Tesla has been given. Area of the coil is length into breadth has been given in centimeters, convert into meters, and just substitute to get the torque. You don't need me doing the sums. You have all these values which has been given. You have to get 198. Torque SI unit is Newton meter, because torque is equal to force into perpendicular distance. Newton meter is the SI unit for torque. Okay, words come to us. If you don't know the sum, you write torque is equal to dash Newton meter also. For Newton, for this, if you're getting low marks, they'll give 1/2 mark for you. Everything that you write in an exam counts. Don't think you don't know sum and leave it like that and come, right? Whatever you know. Okay, so then let's go to next, the formulas. Okay, everything. Okay, so let's go to next sum. That's enough. They won't ask you more than this. We've done more than enough. Okay, there's one NCERT sum here, which I'll do, which is example 74. Rectangular coil of side 8 centimeter and 6 centimeter, having 200 turns, 2000 turns, and carrying a current of 200 milliamps, 200 milliamps, is placed in a uniform magnetic field B is equal to 0.2 Tesla, directed along the positive x direction. The magnetic field is directed along the positive x direction. A rectangular coil of side 8 cm, 6 cm, having 2000 turns, carrying current of 200 milliamps, is placed in a uniform magnetic field along positive x direction. Okay. Is placed. Some rectangular coil is placed in which orientation? I don't know. 2000 turns carrying. That's all is given. Okay, so you have current, you have magnetic fields value, you have number of turns. Okay, is it placed? Current carrying coil. Yeah. What is the maximum torque the coil can experience? What is the torque formula? Torque formula is generally it's a niba. Correct? Generally niba. But okay, I don't know what is the orientation of the coil here. I don't know what is the orientation of the coil. I'm going to pass this. A rectangular coil. So we don't know the orientation of the coil. But all that we have learnt, the magnetic field is along positive x direction. The coil may be like this, or the coil may be like this, perpendicular to the magnetic field. Which will produce maximum torque is the question. The formula for torque itself is niba sin theta. Why am I not using niba cos theta? That I'll use only if I know the angle between the coil and the magnetic field. Otherwise, in general, I'll only use niba sin theta. So then let's forget about niba, n. You know that, let's consider n is the number of turns. 1 is the number of turns. And Ia into B sin theta, where Ia is nothing but the magnetic moment. So MB, torque or general formula is torque is equal to MB sin theta, or torque is also M cross B. Correct? And so when will the torque be maximum? If this theta is 90 degree. That is, the angle between M and B is 90 degree. Magnetic moment is a vector. B is also vector. How to determine magnetic moment vector? Magnetic moment is itself Ia. It depends on the area vector. Because magnetic moment is a vector, because current is a vector. So whichever direction is the area vector, that's the direction of the magnetic moment. So if the coil is going to be like this, then the normal vector will be along x direction. So then this is the area vector. The area vector and the magnetic field are making an angle 0. Then the torque will be 0. So in that case, if this is the orientation, the torque will be 0. Therefore, necessarily the orientation has to be like this, so that it is in the same plane as where the x-axis is lying. So that the area vector will be outward and the magnetic field will be x-axis. So angle between them will be 90, and sin 90 is 1. That's when the torque will be maximum. So in that case, torque is just MB. And you know M itself is Ia into B. But you know that n number of turns means M becomes NIA into B. So you know the number of turns now. What is the number of turns given in the question? 2000 turns. What is the current? 200 milliamps. 200 into 10 to the power minus 3 into, what is the area? Length into breadth is 8 6 of 48 into 10 to the power. You'll get a minus 4, right? Yeah. 8 centimeter. 8 into 8 6 of 48 centimeter square. A centimeter square into meter square is 48 into 10 to the power minus 2 the whole square, which is 10 to the power minus 4. What next? Magnetic field was 0.2 Tesla. If you multiply all this, you'll automatically get your torque value. Are you clear? Which has got to be 0.384 Newton meter again. Make sure everything is in SI unit. That's the only thing. Are you clear? It's such a beautiful sum. Such a beautiful sum. It's an NCERT sum. Okay, so then let's go to next sum. It's example 77. Example 77. A 100-ton coil. Wound circular coil of radius 10 centimeter, which is 10 into 10 to the power minus 2 meter, carries a current of 3.2 amps. What is the field at the center of the coil? Magnetic field B. At the center of the coil. Okay. What is the magnetic moment of this arrangement? Okay. First of all, we don't know. Our question is not over. Such a huge question in the textbook. The coil is placed in a vertical plane and is free to rotate about this horizontal axis, which coincides with its diameter. If you're placing it in a vertical plane, this is the axis of rotation. It's going to rotate like this. The coil is placed in a vertical plane, free to rotate about its horizontal axis. Yeah? Which coincides with its diameter. So it's going to flip like that, correct? A uniform magnetic field of 2 Tesla in a horizontal direction B is 2 Tesla exists such that initially the axis of the coil is in its diameter of the field. The coil rotates through an angle of 90 degree. No, like this. I think so. I don't know. 90 degree under the influence of magnetic field. What are the magnitudes of the torque on the coil? Okay. See, there's a huge question in the textbook. There's a huge question in the textbook which is all omitted. Okay, this part of it is omitted. Second part. So I'll do only the first part and stop it. Okay. No wonder the sum is different. Okay. So then the question, all that it says is it's got a 100 closely wound circular coil. It's like a solenoid. 100 closely wound circular coil is like a solenoid of radius 10 centimeter. Yeah. And carrying current of 3.2 amps. Ni. I is not just I, it's Ni. Yeah. N is 100 turns. What is the field at the center of the coil? For a one circular coil itself, what is the magnetic field at the center? Is mu naught by 2 into I by A. So you just put a N here for a solenoid. I mean, if it's N turns, that's all. So magnetic field is mu naught by 2 into Ni by A. Just substitute everything, you get the magnetic field center. That is not the issue. The second part of the question is what gets difficult. Okay. What is the magnetic moment of the arrangement is also something we can write. Magnetic moment is always. Okay. Do you know what is the magnetic moment? Is I into A or Nia? And do you know N, number of turns? Yes. Do you know I? It's been given. Do you know the area? It's been given. Radius has been given. So you know all this value, you can find the magnetic moment. What will be the SI unit of magnetic moment? Magnetic moment, as the name suggests, is IA, which is ampere meter square. That's the SI unit. So you should find this answer, right? Ampere meter square. So you're sorted. That part of the question is not difficult. But suddenly they're doing another question, rotating about, flipping like this and all. That's not there for the portions. So therefore I can omit it. Are you clear? Oh, thank God. So then let's go to next part. Yeah, these questions will come. So then it's a CBSE question here. So let's do that. It's example 68. I'm coming in reverse in this. Example 68. A rectangular coil, a rectangular loop of side 25 centimeter and 10 centimeter. 25 centimeter and 10 centimeter. Carrying a current of 15 amps. Always the current will be anti-clockwise, okay? Carrying current of 15 amps. Is always see, it is, if it's not given, it's anti-clockwise. It's given also, you see if it's anti-clockwise. It's placed with its longer side parallel to the long straight wire. The longer side is parallel to the long straight wire. 2 centimeter apart. 2 centimeter apart, carrying a current of 25 amps. There is a 25 amps current flowing through here. There is a 15 amps current which is flowing through that rectangular coil. The distance between the rectangular coil and the straight wire itself is 2 centimeter. Okay. What is the net force on the loop? What is the net force on the loop due to this? Okay, can you see? I'm going to teach you something. Can you see this wire is like this? This 25 centimeter wire, they both are carrying current in the same direction. They're carrying current in the same direction, will undergo attractive force. You know this is going to be pulled towards each other. You know, parallel connecting wires carrying current in the same direction will be attracted. So it's going to pull. Whereas this and that, you know, the last wire, the first wire and the last wire, carrying current in the opposite direction. So it's going to get repelled. Okay. So then let's calculate the, okay, but you know that this is closer and this is far away. And you know the formula for F between two parallel wires is F is equal to mu naught by 4 pi into 2 I1 I2 L by A. This is the formula you should have memorized. So this is the force on one. Let's calculate let's name this as AB, and let's do a force on AB, and then this is CD, and then you can do force on CD separately. Correct? Sorry. 15 amps, right? Yeah. So force on AB is mu naught by 4 pi into 2 into I1 is 25 into I2 is 15 into L. This L, we'll always take the two lengths to be the same. You can't possibly take it the longer wire, you have to take it as the length of it, which is 25 into 10 to the power minus 2, which is shorter length, by A is the distance separation between them. It's 2 into 10 to the power minus 2. Mu naught by 4 pi itself is 10 to the power minus 7. Because mu naught itself 4 pi into 10 to the power minus 1, 4 pi get cancelled, into 2 into 25 into 15 into 25 into 10 to the power minus 2, 10 to the power minus 2 get cancelled by 2, 2 also get cancelled. You get some answer here. 25 5s are 625, 625 into 15. Okay, 15 5s are 75, 15 2s are 30, 37, 15 6 are 99, 375. Yeah, good. So 9375 into 10 to the power minus 7 is the force FAB. Force on AB due to the long conducting wire. Now let's do the force on CD. Let me do it on the side. Can I? Yeah. Force on CD will also be mu naught by 4 pi into 2 into I1 I2, which is the same 25 into 15. So 2 into 25 into 15 into can I write it a little left? Is equal to mu naught by 4 pi into 2 into what is I1? 25. What is I2? 15 into the length is again 25. Very good. Into 10 to the power minus 2 by separation is not 2. The separation will be now 10. This distance is 10. This distance is 2. 10 plus 2? 14. So 14 into 10 to the power minus 2. Are you clear? What's the issue? This is 2 centimeter. This is 10 centimeters. So I should write 12. I'm sorry. Sorry. Bang on. 12 into 10 to the power minus 2 is A. Correct? So then calculate this value. You know it's mu naught. It's a 10 to the power minus 7. And this as usual is the same value, right? Only the denominator is going to change. It's 2 into 10 to the power minus 2. This and this get cancelled. Yeah? Here 12. Okay. So 25, 25 sir. We can cancel this with 5 tables. No, 3 tables. 5 by 4. Correct? 25, 25 sir. This and this gets cancelled. Yeah? 25, 25 sir. 625. 625 into 5 is 5 5s are 25, 5 2s are 10, 12, 6 5 30, 3 1 2 5 divided by 2 will be 2 1s are 2, 5 2s are 10, 2 2 2s are 4, 1562.5. Bang on. So then therefore you get this force to be 1562.5 into 10 to the power minus 7. Correct? Yeah, fine. So this is force on CD. And which force is more? Obviously the one which is closer will be more than the one which is farther away. And you know FAB will be greater than. So net force will be this force minus this force. So FAB minus FCD will be the net force. இது பக்கத்துல இருக்குது அது தள்ளுது. ஆக மொத்தம் ரெண்டுத்தையும் subtract பண்ணும்போது you get 9375 into 10 to the power minus 7 minus 1562 into 10 to the power minus 7. You solve it, you get 7.8 into 10 to the power minus 4 Newton to be the net force. Is it easy? Is it easy? So then that's very, very important sum. sometimes I've seen sums like this. I'll just tell you, it's not a part of this question. They'll ask you whether this will have any torque. This is pulling this side, that's pulling that side. Will it execute any torque? Okay, torque means is mb sine theta. Okay, when theta is 0, there will be no torque. Theta is the angle between m and b. In other words, the angle between area and magnetic field. Yeah? The area of this coil is outward. Magnetic field here is, let's see, due to this long conducting wire, the magnetic field will be inward. It's 180, so there will be no torque. Do you understand? You keep your thumb pointing this direction. The magnetic field is outward. It will come from here, it is coming outward. So at the center of this coil, the magnetic field is outward. The area vector is also outward. The angle between them is 0. So torque will be 0. So the same question, if they add, asking you if there will be a torque will be 0. These are world's most important sums. நீங்கள் போய் நாளைக்கு இதெல்லாம் முடிச்சிடணும். ஹாலிடே தானே, இதெல்லாம் இப்போயே கரைச்சி குடிச்சிடணும். இதெல்லாம் ஒரு எக்ஸாமுக்கும் வந்திருக்கு சிபிஎஸ்சி. பண்ணி கணிசி 2005 போட்டிருக்கான், பட்டில் வந்திருக்கு, எவ்ரி இயர் வந்திருக்கு. நெக்ஸ்ட் சம் போகலாம். எக்ஸாம்பிள் 27, எக்ஸாம்பிள் 67, சாரி நான் வளர்றேன், ஐம் டயர்டு, பட் பேர் வித் மீ. கரண்ட் பேலன்ஸா பேங்க் பேலன்ஸ் மாதிரி ஞாபகம் வருது எனக்கு. கரண்ட் பேலன்ஸ், ஆம்பியர் பேலன்ஸ் இஸ் அ டிவைஸ் ஃபார் மெஷரிங் கரண்ட்ஸ். த கரண்ட் டு பி மெஷர்ட், இதெல்லாம் வரப்போகுது ரெக்கார்டிங்கில். த கரண்ட் டு பி மெஷர்ட் இஸ் அரேஞ்ச் டு கோ த்ரூ 2 long parallel wires of equal length in opposite direction. Yeah, current is flowing in the opposite direction, it has to repel. Yeah. The resultant repulsive force on the wire is balanced by putting a suitable mass on the scale pan hanging on the other side of the pivot. இந்த 2 வயர் இருக்குடா கண்ணு, அது ரெண்டுத்துல கரண்ட் ஆப்போசிட்டாக போகுது. இந்த ஃபோர்ஸ் ஆஃப் ரிப்பல்ஷனை நம்ம என்ன பண்ணுறோம், இந்த இடத்துல வந்து ஒரு வெயிங் பேன் மாதிரி மெஷர் பண்ண, அந்த ஸ்ப்ரிங் பேலன்ஸ் எவ்வளோ ரீடிங் கீழே வருதோ தட் மச் வில் பி த ரிப்பல்சிவ் ஃபோர்ஸ், சம்திங் லைக் தட். யூ கேன் இமேஜின். நோ, புரியுதா? நான் ஏனோ புரிஞ்சுக்கிறேன். இங்கே ஒரு ஸ்ப்ரிங் பேலன்ஸ் இருக்குன்னு வச்சுக்கோங்க, எவ்வளோ ரிப்பல்சிவ் ஃபோர்ஸோ அந்த அளவுக்கு இந்த ஸ்ப்ரிங் பேலன்ஸ் வில் கோ டவுன், அப்படி தான் நினைக்கிறேன். பார்க்கலாம். The resulting repulsive force on the wire is balanced by putting a suitable mass on the scale pan hanging on the other side of the pivot. If one measurement is, repulsive force is getting balancedங்கிறான். நான் வந்து repulsive force is pushing the spring balance மாதிரி சொல்கிறேன், தெரியல எனக்கு. If in one measurement the mass in the scale pan is 30 grams, the length of the wire is 50 centimeter each, and the separation between them is 10 millimeter. What is the value of the current being measured? இதில் 4 current என்னன்னு கேட்குறான். Okay, all that I don't want to draw this. All I can say is the repulsive force is being balanced by a weighing pan or some 30 grams weight. 30 grams weight now, let's see, mg will be the repulsive force. Okay, let me construct it like this only. I don't know how is it balanced here, but I know that there's a weighing pan and there will be an mg where a scale pan is, this is showing 30 grams. M into G will be 30 into 9.8 or 10 வச்சுக்கோங்க, mg. That has to balance the force of repulsion. இந்த டயக்ராமில் அது கேட்காது, ஏன்னா ஃபோர்ஸ் ஆஃப் ரிப்பல்ஷன்னா இதுவும் கீழே தான் வரப்போகுது, இது அங்கே தான் வரப்போகுது. I think I understood. I think I'm going to attach this pan to the other wire so that the upward force can be countered by the downward mg. Sorted. Okay. Sorted. Okay. So then therefore this mg is equal to force of repulsion of this. The force of repulsion on this and that is the same, and the formula is mu naught by 4 pi into 2 into I1 I2 into L by A, and the mg itself is 30 into 10. Mu naught by 4 pi is 10 to the power minus 7 into 2 into what is I1 and I2? What is I1? Have we given I1 I2 in the sum? No, that's what you have to find. Can we consider take it as I square? Because it's the same current. Have they given same current? A current balance, the current to be measured is arranged in resultant repulsive force. If one of the measurements, it has got to be I, okay, same current, so I square. It's got to be, otherwise we can't do it. Length is the length of the wire. Length of the wire is being given 50, yeah? So into 50 into 10 to the power minus 2 by the separation between them 10 millimeter, huh? So 10 into 10 to the power minus 3. So with this we cross multiply and get I square. That's what I square really correct. It's absolutely right. So it can't be, if it's I1 I2 we can't find, we can only find the products of the current. So that completes the sum. I'm not doing it. Quite complex sum to understand the question, correct? So let's go to next sum. Is this a CBSE marked sum? There's also one more NCRT here. There's also one more NCRT, which is example 61. On a smooth plane inclined at an angle 30 degree with a horizontal, a thin current carrying metallic rod is placed parallel to the horizontal ground. A thin metallic rod is placed parallel to the ground, means this has to be the rod, right? Because it has to be parallel to the ground. But how can you place it on the inclined plane? I really don't know. I'm struggling. No, that's not. On a smooth plane, inclined angle 30 degree with a horizontal, a thin current carrying metallic wire is placed parallel to the horizontal ground. How can you place it on the inclined plane? See, this is the inclined plane, okay? How can you place a wire on this which will be parallel to the ground? Because that itself is a slanting area, so then slanting portion. No, plane is located in the plane is located in a uniform magnetic field of 0.15 Tesla in the vertical direction. So there is a magnetic field in the vertical direction. I'm struggling to do the sum, so I'm passing this and I'll do it later. See, this sum is a very, very complex sum. I don't think it will come, it's never come for any exams, but having said that, let's learn it properly. You have an inclined plane which is like this. Okay, there's a rod here which is like, I can show you if you're in offline class only, but you can understand that there is a rod which is like this. Which is like this. A PQ is the rod which can be rolling along the inclined plane like that. I hope people can imagine that the rod can roll like this throughout the plane. So that's what it is. I'm able to explain only so much. That's a rod PQ. But that rod PQ is going to make an angle. There will be an mg of the rod which is acting downward, directly downward, and this angle between them is theta. And then this, you know, when in an inclined plane, when there's a block, there will be an mg, and if the angle of repose is theta, this will also be theta, so you'll write mg cos theta, and this will be mg sin theta. So then you know if it is going to slide down, it's going to slide down with mg sin theta, and this should not slide down. There has to be a force in the opposite direction. That force has to balance, and that can be balanced only by means of magnetic field. You will all think it's BIL because that's a force on the rod, but it's not BIL, it's BIL cos theta. Why is it BIL cos theta? Is they are saying the magnetic field is upward, like place a pen on this point here, okay, with the base of the pen on this point. That is the direction which magnetic field is, and the current carrying wire is in this direction. The angle between the length L cross B is where the force is. So then therefore you have to cross this and this mutually perpendicular. This is like a Z and that is like a Y, and so along the X direction is your BIL. You have to assume this is theta, so this will be BIL cos theta. Therefore this mg sin theta, which is responsible for rolling down, should be countered by BIL cos theta. Are you clear? So then therefore if you want to find I from here, it is mg sin theta by BL cos theta, or mg by BL into tan theta. You know the angle is given to be 30 degree. So directly substitute there, and you know that m is the mass of the rod. Mass per unit length has been given with 0.03 kg per meter cube. Can you see an m by L, which itself is mass per unit length? Directly you can substitute. Gravity is g, magnetic field is given to be 0.15, so directly substitute everything. You tan theta you write, you get the value of 11.32 amps. Oh my god, that was a very, very challenging sum. To understand the question how it is, I hope I made it clear. For people who are offline will understand it better. So can I go to next? The next sum, did I record it? Yes, I recorded, right? Okay. The example 63. A solenoid of 60 centimeter long, 60 centimeter long and a 4 centimeter radius has 3 layers of windings of 300 turns, means one layer, another second layer, another third layer, which means each means 300 turns is there in one layer. So 300 to 3 will be 900 turns will be the total number of turns if you consider everything, and the current has to be multiplied by it, correct? A 2 centimeter wire of mass 2.5 grams lies inside the solenoid near its center normal to the axis. A wire, 2 centimeter long wire, 2 centimeter long wire, which means like this. It's not a coil. It's not a coil. A 2 centimeter long wire of 2.5 grams lies inside near its center normal to the axis means, can I say the wire is going to be like this, which is normal to the axis because the axis of the solenoid is like this. So it seems to be a 2 centimeter long wire. I hope I'm doing it correctly. Let's see. So it's a 2 centimeter long wire, which is straight wire, which is 2 into 10 to the power minus 2 meter. Lies inside the solenoid near its center normal to the axis. Both the wire and the axis of solenoid are in a horizontal plane. Both the wire is in the horizontal plane. We have drawn it like this, right? So which means the wire has to be like this, huh? Wire is placed in parallel to the magnetic field or normal to the magnetic field. What was given in the question?
Normal to its axis.
A solenoid 60 cm long, radius 4 cm, has 3 layers of windings with 300 turns each. A 2 cm long wire of mass 2.5 grams lies inside near its center normal to its axis. Means I have to draw like this only, no? 2 centimeter long. Let's figure that out. We'll read the question later when we can infer. Both the wires and the axis of solenoid on the horizontal plane. Let it be, leave that point. The wire is connected through the 2 leads parallel to the axis. Wire is connected through 2 leads parallel to the axis of the solenoid to an external battery which supplies the current of 6 amps to the wire. This wire is connected to a battery which supplies it with a 6 amps current. What is the value of the current in the windings of the solenoid? What is the value of the current in the windings of the solenoid can support the weight of the wire? So this wire should not fall down. So then the mg of the wire should be countered by some force. Correct? And the force is again on the long wire is BIL. So mg has to be countered by BIL. That much you know. Correct? So the mg has to be countered by a BIL. And do you know B? What produces the B? It's a solenoid. The magnetic field is produced by solenoid. The magnetic field of solenoid is mu naught into small n into I. So mu naught into small n into I. Mu naught itself is 4 pi into 10 to the power minus 7. Into small n is the number of turns per unit length, which itself is total number of turns. Total turns by total length. Total length. What is the total turns? Is 900. By total length is 60 into 10 to the power minus 2. So then therefore this will be 1500 turns per meter. That's a small n. So mu naught itself is 4 pi into 10 to the power minus 7 into 1500 into current I. Have they given current I? 6 amps. Supplies it. Have they given I through the solenoid? What should be the current through the solenoid? They have not given it. Correct? Yeah. Yeah, so you should write like this and leave it like this. Because you don't know the current through the solenoid. But all that you know is the current of 6 amps flows through the little wire. Correct? So then this is it. And you know this is the magnetic field due to solenoid, which is going to act on this wire, which is going to produce a BIL on the wire. So then the force on the wire is BIL, which is this value of B, and the current in the wire, which is 6 amps in the wire. Correct? And the length of the wire. Do you know the length of the wire? 2 centimeter long wire. Correct? So then let's do it. 4 pi into 10 to the power minus 7 into 1500 into I should be, this is just B, right? Just B of the and that B into IL of the rod. Of the rod, and I of the rod is 6.
2 centimeters long.
6 amps, right? 6 amps sends out a 6 amps current. IL, current carrying rod, has got 6 amps current, into L of the wire, which is 2 centimeter, which is 2 into 10 to the power minus 2. So this is my BIL. I've written an essay about BIL. Let me see if it's correct, okay? B dash itself, okay, B dash IL, which is 6 into 2 into 10 to the power minus 2 into 6 pi into 10 to the power. This is nothing but 15. So can you see? Yeah, this is what they have done. Yeah, correct. So thus you get the force on the wire. This has to be countered by mg. You think so? The current I would support the wire, which is equal to mg. As I said, it has to be countered by mg. What is m of the rod? M of the rod is 2.5 grams. You have to convert into kg. 2.5 into 10 to the power minus 3 into 9.8. So with which you can find what should be your I. Beautiful sum. To read the question, it's very difficult to understand when you read as a para. But as you put it, you know, wire means BIL. And to find BIL, where is B coming from? It's coming from the solenoid. What is B of solenoid? Mu naught into small n into I. But that I you don't know. That's the question. So small n is capital N by L. So you know total turns and by L, and it's self-explanatory. Can I go to next question? Is the 59th example 59. A straight wire of mass 200 grams. 200 grams. When I say straight wire, I'm thinking of doing only BIL. Whenever I can only think of BIL. But the B may come from somewhere, which is either it's given or can come from a solenoid, can come from any other current carrying wire. You never know. So straight wire of mass 200 grams and length 1.5 meter carries a current of 2 amps. It is suspended in mid-air by uniform horizontal magnetic field. What is the magnitude of? So this is lying because of the magnetic field. You know, mg is countered by BIL. Simple sum. No confusion. If it's lying like that because of the magnetic field, then downward force has to be equal to upward, which is BIL. So mg is equal to BIL. You know everything. Mg 200 grams into 10 to the power minus 3 into 10. Left side is over. Magnetic field is B. Has magnetic field been given? It's not been given. You know the magnetic field due to current carrying wire will be mu naught by 4 pi into 2I by A if it's infinitely long wire. I don't know if that's what it's an infinitely long wire. Of length is 1.5 meters. So it's not infinite. So is it a part of square? There's a lot of doubts that we still have. So I don't know. Let's see. Okay, so then that's all is the question. Okay, to find the magnetic field. Oh, you can just equate. Everything has been given. I'm sorry. Can you see everything here has been given? You don't have to find in any other way because B is something you don't know. But you know what is the current? The current is 2 amps. In length of the wire is 1.5. So everything has been given. You can find B. You don't have to go for mu naught by 4 pi into A by A because you know mg here. That's getting balanced. So the sum is so simple. So can I go to next? Tesla is the unit for magnetic field. Can I go to next sum? Example 58. Okay, magnetic field of 1 Tesla is produced by an electromagnet on the cylindrical region of radius 4 centimeter. Let me draw this, okay. There's a wire like this, where there's a current I. There is the north pole, some cylindrical, I don't know what this is, this way that they have drawn it. I'm going to read the question. A magnetic field of 1 Tesla is produced by an electromagnet in a cylindrical region of radius 4 centimeter. In this region, radius is 4 centimeter. A wire carrying current of 2 amps is placed in perpendicular to the, you know, magnetic field is always from north to south. The current carrying wire is perpendicular to it, correct? Is placed perpendicular intersecting the axis of the cylindrical region. Find the magnetic force on the wire. So the magnetic field is in this direction, going from north to south, and the radius of this region is R is equal to 4 centimeter, no? 4 centimeter, I don't know, okay. There's a current carrying wire. Find the magnetic field acting on the wire. Normally magnetic field acting on the wire, it's BIL. Any wire, the force is always BIL sin theta. The current L and B is 90 degree. The length and the magnetic field are perpendicular. So we can just say BIL sine 90, so BIL. The force acting on the rod, so B, what is B? Have they given the magnetic field? 1 Tesla.
Yeah.
Into current. The current carrying wire is carrying a current of 2 amps. Into length of the wire is 4 centimeter. Correct? Which is 4 into 10 to the power minus 2. Is it 4 centimeter length of the wire? Radius is, okay, not the length. So if the, if the radius is 4 centimeter, the length of the wire which is going to lie within the region of the magnetic field, can I take it as 8? So it's 8 centimeter. So then therefore 0.08. So that's sorted, you're getting the force on the rod. That's all. Are you clear? Can I go to the next question? NCERT. Example 56. The horizontal component of the Earth's magnetic field. That's not there in portions, right? Horizontal component of Earth's magnetic field. Horizontal component is not there. That part of the portions is not there for you. Okay, and we'll take it. Want me to take it or not? But சொல்லித்தரேன். Example 47 சொல்லித்தரேன். See, இது வந்து நான் தியரியிலே எடுக்கல, ஏன்னா சைக்ளோட்ரான் கிடையாது அப்படின்றதுனால. பட் சைக்ளோட்ரான் கிடையாதே தவிர, பட் யூ நோ தட் when a particle is going with a velocity v making an angle theta, it will take a helical path நான் சொல்லி கொடுத்துருக்கேன். Where there's radius, you know, any circular motion will have centripetal force which is mv square by r, which is equal to Lorentz force which is qvb. Angle between v and b நான் 90 degree எடுத்துக்கிட்டேன்னா, சப்போஸ் இது ஹெலிக்கல் பாத் விட்டுற சர்க்குலர் பாத்துக்கு வந்துரு, where v and b is 90 degree. ஞாபகம் இருக்கா? It'll take a circular path ன்னு சொல்லியிருக்கேன். So then VB is 90 sin theta ன்னு வச்சுக்கோ. So V and V get cancelled. So இதுலேருந்து நீ என்னெல்லாம் பண்ணலாம் தெரியுமா? இந்த இதில் இது வந்து helical path. I'm talking about a circular path. So MV by R is equal to QB. So R is equal to MV by QB ன்னு ஒரு ஃபார்முலா கிடைக்கும். If any charge particle is taking a rotational motion in a magnetic field, the radius of circular path is MV by QB. You just equate a centripetal force with QVB and you can derive many formulas. If you want to find the formula for velocity is Bekar by M, BQR by M. I call it as Bekar by M. Supposing you want the kinetic energy is half M V square. So multiply here also with half M V square, which is B square Q square R square by M square. M and M gets cancelled. Thus you get Bekar the whole square by 2M. Bekar the whole square by 2m is the kinetic energy for these are all. If they are going to ask you questions on a charged particle, say an alpha particle or a proton or anything is revolving around in a magnetic field, they given the magnetic field's value. You know the charge of a proton, alpha particle charge will be helium will be 2q. Okay, whereas charge of an hydrogen will be 1q, which will be 1.6 in 10 to the power minus 19. You can take it like that. So radius, you can, if they give you the radius, you can find the radius if they ask you for the radius, if you know the velocity and magnetic field and charge in them. So sometimes they'll ask you questions like it may be about a charged particle, alpha particle and a hydrogen atom. What do you know about the mass of an alpha particle is 4 times the hydrogen atom. If hydrogen atom's mass is m, then alpha particle will be 4m, because helium is 4 times the mass of hydrogen. So then you will substitute here, you will compare the which one will have greater radius or something like that. Radius of the alpha particle, radius of the hydrogen atom will be 4m. Here it will be mv by qb for a given magnetic field. But the same for a alpha particle will be 4mv by q. What will be the charge for an alpha particle? It will be 2q into b. So then thus you can do the sums using that calculator and say that the radius will be 2 times the radius of the hydrogen atom or things like that. You know, you can compare the radius of the alpha particle, radius of the hydrogen atom. Those things, or you can come across those sums when I give you those extra questions that you will fall in place. You'll start doing those extra sums with others. We have hardly any time left. Just 1.5 months. It's January and mid-February. I have to finish so much for everyone. Okay, so let's go to the next question. And I told you, similarly, when you have electric field and magnetic field, when I ask you for the velocity of the charged particle, you know it's V is equal to E by B. There's a CBSE question here. Am I recording all this? Yes? Example 45. if a particle of charge q is moving with a velocity v along z direction, and the magnetic field B is acting along x direction, and they'll take a circular path. Yeah, Lorentz force is given by q dot v cross B. Find the direction of the force acting on it. Direction of the force acting on it, force is equal to q dot v cross B. What is the direction of V? It's positive k. What is B? Is I. And what is k cross I? J k. A k cross I is J. The force will be acting along positive y direction. Force acting on the charged particle is along past x direction. If a charged particle q is moving along z direction, yeah, along z, magnetic field is along x direction, correct? Is along x direction. It's v cross B, it's k cross I, and a k cross I is nothing but j. The force has to be along j direction, correct? He is writing velocity is along j direction. Velocity is first of all along z direction according to the question, correct?
Yeah.
What he has done and what he has written is something different. What will I do? You understand what is my problem? So then if the question is like this, we will answer like this. He has written the wrong thing. He is saying that in the velocity is along j direction, magnetic field is along k direction. I can't agree. Okay, so then leave it like that. So you know how to answer if it comes. For us, if this is the question, the answer has to be along j direction, which is positive. Force has to be upward direction. And now a beam of proton pass undeflected with a horizontal velocity v through a region of electric and magnetic field mutually perpendicular to each other and normal to the direction of the beam. If the magnitudes of the electric and the magnetic field are 100, okay, they've given the electric field also. It's 100 kilovolt per meter. 100 into 10 to the power 3 volt per meter, which is 10 to the power 5 volt per meter, is the electric field. The magnetic field is 50 millitesla, which is 50 into 10 to the power minus 3 Tesla. Whenever they give you electric field and magnetic field, if they ask you to find the velocity of the beam, V is equal to E by B straight away. So the 10 to the power 5 by 50 into 10 to the power minus 3. Then this goes up 10 to the power 8 by 50. Yeah, you can write as 1 by 5 into 10 in 10 to the power 8. It become 10 to the power 7. 0.2 into 10 to the power 7. Or 2 into 10 to the power 6 meter per second. Straight, don't go into logics. If you know electric field and magnetic field, they ask you for velocity of the beam of particle. V is equal to E by B. Done. Okay. So then next part of the question is, so you found the velocity of the beam. Force with which it strikes the target on the screen. The force with which it strikes the target on the screen. Force with which it's rate of change of momentum. Last year's syllabus, force is equal to dP by dt, where P itself is mass into velocity. Yeah? I don't think the sum will come. Can I omit this sum? This is in 2008. It gets very hard. It's about with 11th standard portions and all. Okay, it's mass of the proton, because it's a beam of proton into number of protons into velocity, because momentum is not given by just one proton. It's mass of the proton into n number of protons into velocity. That will be the total momentum. And do you know the velocity which you found? Yeah? Do you know the number of protons? It's not been given, but they have given current. Current is 0.8 milliamps. And you know I is equal to n into E. The total, so n into E is equal to I. So if you know the current, you can find n, I by E. So 8 into 10 to the power minus 4 by 1.6 into 10 to the power minus 19 will give you n. That n has to go here. Mass of the proton, you know, is 1.6 into 10 to the power minus 27. You know the velocity. This is about the force. First of all, you can't do the sum, because you should remember that it's rate of change of moment, change in momentum. So all that you need is the momentum, the net change in the momentum, which is mass of the proton into n into v. And to find n, if current is given, I is equal to n into E. So n is equal to I by E. That won't strike us. So that's this difficult part. I've anyway done it. Try to not do such difficult sums. That's okay. It's going to be confusing. Don't do it. Okay. So then this sum is CBSE sum example 40. with which I'll try to wind up today's class. It's too much. Okay. Long straight wire carrying a current of AB carries a current of 4 amps. A proton P travels parallel to this wire, but it's going like this, it seems, a proton. Okay. 4 into 10 to the power 6 meter per second is the velocity, and it's at a distance of 0.2 meter from it in the opposite direction, correct? Calculate the force with which the magnetic field of the current exists on the proton. So you know this current carrying wire will produce a magnetic field. It will be inward. Oh yeah. Okay. Can I take it as like this? This is a proton which is flowing in this direction.
Okay.
Can I say that that's a proton? So electron, can I take it as like this? So it will be attractive in nature. So I really don't know. Okay. No. Let's calculate the magnetic field due to this wire. It will be inward. At this point, let's find the magnetic field. It will be inward, and what's the value? Mu naught by 4 pi into 2I by A. So it's mu naught by 4 pi itself is 10 to the power minus 7 into 2 into what is I? 4 by A, separation is 0.2 meters. That will be the magnetic field's value. And the force on this is Lorentz force. F is equal to Q dot V cross B. Q of the proton, charge of the proton, we can take it as 1.6 into 10 to the power minus 19. Yeah? Into velocity V of the proton, 4 into 10 to the power 6. Into B, is this value can be substituted. Hence you can find the force. This is what he has done. Once again, let me check. Yes. P, Q, B, sin theta. Sin theta will be there, V and B, but it will be 90 degree because the magnetic will be inward and the velocity is in this direction. So here it's the Lorentz force sum. That it's not two parallel connecting wires because not a parallel wire. It's just a proton which is going. It's a charged particle moving in a magnetic field. So that completes the sum. So let me just scroll through and see if I've finished major part of it. This one all I've already done. Okay. And magnetic field due to a solenoid is mu naught into small n into I. If you know the current, you can find the magnetic field. You can find small n. Toroid is small n is equal to capital N by 2 pi r if the question is about a toroid, correct? And there are so many other sums which are in here which I have not done, which are very, very important, which we'll have to figure out another day and do. Correct? Can I pass this?